Hello, learners. Welcome to Binpipe. I am Prasanjit. Great to see you. Let's learn about DevSecOps today. We have heard a lot about DevOps, but DevSecOps is a new term that comes up very frequently nowadays. Now, DevOps isn't just about the development and operation teams. If you want to take full advantage of the agility and responsiveness of the DevOps approach, IT security must also play an integrated role in the full cycle of your apps. Why? In the past, the role of security was isolated to a specific team in the final stage of development. Like when the development gets over, people get bothered about security and they would just put up some firewall rules and or ask a third-party agency to secure their systems for them, and that is all. Put up some SSL certificates, maybe host the website on 443, and that's all. But that shouldn't be the approach when you're taking a continuous development, continuous integration, and continuous deployment approach towards your software development. So security has always has to be in the sidelines. I mean, security has to be the pillar that has to be present all the time if you're doing DevOps. So DevSecOps, what is it? Let's understand deeper, and let me share my screen and discuss the nitty-gritties. Here we are. You can see three guys, Dev, Sec, and Ops here. Now, all of them are independent. Developer writes the code, dumps it over on the repository. Security guy checks whether the code is secure or not, and then if it is and the servers are secure, dumps it over to the ops guy, who would now be responsible to have the code in production and maintain reliability of the website or the web application, whatever that thing is. Now, in this way, when all of them are working in silos, it is difficult to pinpoint issues, resolve them fast, and maintain a very reliable piece of software. So here comes in DevSecOps, same as the approach we do in case of DevOps, and break silos, the case where we have people with special abilities and tool chain who take care of development as well as operations in a different approach where everyone is responsible for everything and everyone has a knowledge of the entire flow end to end, and people do not use isolated approaches. They rather use pipelines which automatically trigger off a deployment as soon as the code is pushed into the repository, and then it builds the code, stores the artifact somewhere, and that artifact is then deployed on the production systems. So from environment creation to code build to code deployment, everything is automated using tool chains and using pipelines. So that is the DevOps approach. Similarly, if we embed security in the DevOps approach, if these three guys work together in an automated workflow, then that thing becomes DevSecOps. Now, DevOps ensures rapid and frequent development cycles, sometimes weeks or days, but outdated security practices can undo most efficient DevOps initiatives. Like even if DevOps practices makes your workflow faster, if there are security issues in your application, then that would slow you down in the end. So that is not going to be the most efficient DevOps practice. Now, in the collaborative framework, like in the second picture, where all of them collaborate together and have a shared responsibility, then this entire thing, DevSecOps, is integrated end to end. DevSecOps to emphasize the need to build a security foundation into DevOps initiatives. So DevSecOps makes things secure. makes DevOps secure, makes applications secure, makes the entire practice secure. DevSecOps so essentially means thinking about application and infrastructure security right from the start. It's not that after the system gets built, you do a security scan or hire a third-party provider to find out bugs or security issues in your application, and then you start working on patches and fix them. So when you are practicing DevSecOps, you are taking security seriously right from the start. You're selecting the right tools to continuously integrate security, like agreeing on what IDE to use, what security features to be embedded into the IDE. IDE stands for Integrated Development Environment. Most of you developers or DevOps people would be knowing this. Coming back, however, the effective DevOps security requires more than new tools. It builds on cultural changes of DevOps to integrate and work with security teams sooner than later. So what happens? We use the security expertise in the DevOps team and use them fast. Like as soon as the code is written, we keep in view what security practices to be followed, and that has to be kept in mind. Now, whether we call it DevOps or DevSecOps, it has always been ideal to include security as an integral part of the entire app lifecycle. Now, DevSecOps is about built-in security, not security that functions as a perimeter around the apps and data. So it is always with the development lifecycle. So it is not something which is in the periphery. If security remains at the end of the development pipeline, organizations adopting DevOps can find themselves back to long development cycle, because if there is a bug that comes up and there is no security that has been taken out during the development, then again you're going to slow down in the end. So in part, DevSecOps highlights the need to invite security teams at the outset of DevOps initiatives to build in the information security and set a plan for security automation as well. It also underlines the need to help developers code with security in mind. It is a process that involves security teams sharing visibility, feedback, and insights on known threats. It is possible that this can include new security training for developers too, since it hasn't been a focus in the traditional application development. So what does built-in security really look like? For starters, a good DevSecOps strategy is to determine risk tolerance, number one, and conduct a risk-benefit analysis, number two. So I'm going to explain what these terms are. The developers also have to know what amount of security controls are necessary with a given app. Like if the app is having payment data, then it has to be very secure. If the app is just a game app which doesn't capture any login information and is an open app, then you need not be bothered about security of the user or the payment data. So you can lower down your security guards. So it depends on what kind of app it is, what information it captures, what purpose it serves. So all that allows to develop a good security strategy, and the developers are briefed accordingly, like how far to raise their guardrails when security is concerned. But security should always be ingrained in the process, not something to be done in the end. Now, automating repeated tasks is key to DevSecOps, since running manual security checks in the pipeline is time consuming. So similarly, security checks are also embedded in the pipeline and happen automatically. Now, with DevSecOps, the security is automated. So that is the thing that happens with DevSecOps. The entire security cycle is embedded in the pipeline, and organizations put in security tests and checks in the CI/CD pipeline, and this runs all the time whenever that pipeline is executed. So as soon as the code is pushed, there would be a security check or a code sniff, and whatever possible or probable threats are detected, they are immediately reported back to the development team. So that speaks of the continuous feedback approach in DevOps. Now, another point is DevOps security is built for containers and microservices. Now, since we use cloud native technologies and deploy everything as containers, and using different orchestrators like Kubernetes, and we put them up in the cloud. So it is imperative not just to scan the code for threats, but to scan the Docker images, to scan the entire infrastructure on the cloud, whether they have any vulnerabilities. So that has to be done. Now, how that is achieved for environment and data security, standardize and automate the environment. That is very important. Each service should have at least least privilege possible, least exposure. Then centralize user identity and access control capabilities. So you have a single sign-on process where each team member has to authenticate themselves, and everything is like the cloud governance happens from a single point. So that allows to have an eye on the entire user base, so there are no slip-ups. For example, say you have a database and you have a database user, different sets of database users. You have an application, you have different sets of application users, SSH users. If you have multiple credentials for the same user, it would be difficult to manage and maintain. So centralizing user identity and access control makes a very good and secure application level in terms of cloud governance. Then isolating containers running microservices from each other and the network. Like, each container should be independent and should be isolated. So even if one of the containers is compromised, that doesn't create a chain reaction across your applications, because all microservices are interlinked. So that should be kept in mind. Data should be encrypted between apps and services so that there are no man-in-the-middle attacks, and there is no sniffing, and data is encrypted when it travels through the network. Further, gateway APIs, API gateways should be secure and should have authorization, should be using secure socket layer, and should be having less exposed surfaces for attacks so that the attacks can be minimized. So that is about environment and data security. Next, we have to keep an eye on the process security when we are talking about DevSecOps. So DevSecOps also takes care of the pipeline process security. So you have security scans embedded in your CI/CD pipeline. So integrate security scanners for containers, automate security testing in the CI process, the one which I discussed some time ago. We have to have code scans. So for that we use some security tools, and we scan the code and we highlight the known vulnerabilities if there are any, and the best practices. And further, add automated tests for security capabilities. that is self-explanatory. Automate security updates and patching. Whenever one should not delay patching, one should immediately go for it and then fix the incompatibilities. And all of this and configuration management should be automated and secure. If a human does it, it could be an error-prone system. So tools such as Ansible would help in that case. So what are the tools that are used in a DevSecOps tool chain? Here you can see this infinity model, similar to what we have in DevOps. This is the infinity model for DevSecOps. So we can discuss how it works. Now we begin from here, plan phase, and go on here in the infinite loop this way till we reach the adapt phase. So in the plan phase, what happens? When I'm discussing this, I'm only concentrating on the security aspects and not focusing on the DevOps. So in DevOps, what happens? Plan, create, verify, then release and respond, feedback and deploy. So in DevOps, what happens? We plan a product, we create the product, we build the product, test the product, and then we deploy the product, we get the feedback and complete the loop. And that goes on continuously. So that is the continuous integration and continuous deployment process in DevOps. Now in DevSecOps, there are some extra phases, of course, like we verify changes. This verify doesn't mean just testing, it means security testing, security tests. So in the plan phase, we address technical security debts, DevSec, metrics, threat modeling, security tool training, and all that. So we'll be going deep into all these in other videos. This video is a primer for DevSecOps. This is about what DevSecOps is and what are the high-level things that are comprised in this process. So we will go through all these parameters in future videos based on your feedback, whether you like it or not, and keep working and improving our video and our tutorials here. So coming back, in the plan phase, we discuss and plan the threats to that application and what should be the approach. And then in the create phase, we implement certain plugins in our IDEs where we write our code so that the security threats are immediately detected and informed to the developer so that he can fix it right away. And then it moves on to the verify phase where the SAST, DAST, IST, SCA, all these security threat checking is done. Okay. And after that, when it moves on to the environment, this is the pre-prod environment, could be a test environment or a staging environment. There we run certain kind of chaos tests. Chaos engineering is a process where you fail your environment components. Say you have 5 servers, you fail 2 of them. You put down one of the databases from a database cluster and see how the application reacts to it, whether the application breaks and exposes security vulnerabilities due to this chaos tests. So that is done, input fuzzing is done, integration tests are conducted. So once this is done and it passes the pre-prod environment, it moves on to the software signing phase, and that's when the software is released. And there is a prevent phase where signature verification, integrity checks, defense in-depth measures are done. And then there is another set of tests, RASP, UBA, network monitoring, penetration tests that is being done here. All these can be automated, and you might be thinking this is too complicated. It is not, because all these would be embedded in your pipeline, and it depends on how many of these you will include in your pipeline, because Of course, these tests will take time, and what should be the frequency? All that depends upon your plan phase. Like, say, if the application is not that vulnerable, you can, of course, skip some of these phases. So after all this is done, there is a response phase where security orchestration, RASP, WAF shielding, obfuscation, all these things are done. Where you do the code obfuscation, you have your WAF firewall shielding, which ports to close, which ports to expose, which IPs to allow, whitelist, which not, and all that is done. Once that is done, then finally is the predict phase, dev consumable correlated vulnerability analysis. All these are done. Now, once that is clear again, then goes to the adapt phase, security, technical debt, modify, resistant response. Here what happens if there is something new that has come up, some new vulnerability has been detected, and or something in the underlying software has changed that needs patches. All these things are done and goes back to the plan phase again for the next iteration of the application. So that way this infinite loop goes on for the DevSecOps tool chain. So that is how DevSecOps operates, and it makes your security very easy. Initially difficult to approach because this is an entirely new paradigm, but once the entire pipeline and the processes and the security scans are set up, then it becomes a part of life for the DevSecOps team as well as the entire software organization. So that is all about DevSecOps. Hope you learned out of it. Keep learning, keep watching my videos, and let me know what next you would need to learn and what are you focusing on. Stay tuned, keep learning. Thanks.